These are the answers of the tutorial for the second part of the performance task. And again, 3 was in 3 parts. And so on the first part of the performance task, I had done 3A. And it talked about how there was Ned had missed the bus. And these were the number of minutes he was away from school. So X values were the number of minutes he was away from school. And Y, the Y values, was the distance he was away from school in meters. And so I wrote those up there because we'll need them for this next part. And part B says, well, let's go ahead and take those values and plot them on a coordinate plane. So I'm going to sketch a coordinate plane. And I'm going to say that my X values are, again, time in minutes. And I'll just go ahead and put in these number of minutes. So this is 2, 4, 6, 8, 10. So there's the 10 minutes. And then we have to go up to 200. So I'm going to count by 20s. So that's 20, and this would be 40 here. 80, 120, 160, and 200. Alright, so I'll be able to fit everything now. And then this is the number of meters from school. And so what they want us to do is go ahead and graph this and then explain where is the graph increasing, where is it decreasing. So let's go ahead and graph these points. So 1, we were 20 meters from school. So that's the point there. I'll change colors here so it's a little bit easier to see. And so we were 20 meters from school after 1 minute. And then after 2 minutes, we were 60 meters from school. And then after, looks like 3 minutes, we were 120 minutes from school. And then after 5 minutes, so we skip all the way to 5, then we're just 100 meters. So it looks like we went backwards. And then after 8 minutes, we were still just 100 meters from school. And then after 10 minutes, we were 200 meters from school. So this is what the graph ends up looking like. So those are the points. And then I'm just connecting the points with lines, segments. And that's what we've got. So now they ask, where is the graph increasing, where is it decreasing? Well, it's increasing, we'll say. Increasing. And I'll talk about with respect to the minutes here. So from 1 minute to 3 minutes, it's increasing. So 1 minute to 3 minutes, it was increasing. And then also, here it was decreasing, so this here was stagnant. It wasn't changing at all. But then from 8 to 10, it was also increasing. So from 8 minutes to 10 minutes, it was also increasing. So that was the increasing part. Now, decreasing, we've got from 3 minutes to, and then we went all the way over, looks like it decreased to 5 minutes. 3 minutes to 5 minutes is where it was decreasing. So then in part C, then they ask us, well, what was happening between 5 and 8 minutes? What was going on when he did not change that distance? And that's exactly what happened. So Ned stopped at 5 minutes and did not resume walking until 8 minutes. So that was the reasoning there. He had something he had to stop for and did not move any closer or further from school. So that was part 3. Now we'll take a look at 4. And 4 says that Al averages 10 miles an hour while biking from Placerville to Davis, a distance of 63 miles. And Al is going to the UC Davis Aggies take on the feared South Dakota State Jackrabbits. And the game starts at 7 p.m., and if it takes him 15 minutes to get through the gate into his seat, by what time must Al leave Placerville to arrive on time? So we're figuring that he's going to arrive directly on time, so not even a minute to spare. So what we're going to do is set up an equation, because that's what they ask us to do. So let's go ahead and define some of our variables here. I'm going to say that y equals the total distance in miles. So it's always nice to define your variables so you know what they mean when you're trying to solve for something. And x is the time in hours. So what we're going to end up doing is looking at where the variable term is. And we have no starting amount. It's not like he started 10 minutes or 10 miles into his 63 miles, so we have no starting amount. All we have is a variable term here, the 10 miles per hour. Now I know it's a variable term because of that word per. So the total distance is going to equal his average biking speed, 10 miles per and then hour. And then we're going to multiply by the number of hours. And so that's going to be my x value. And so now we're ready to solve. So they ask us, well, at what time must he leave? And how many hours early should he leave? Well, if it's 63 miles, so this time instead of putting the number in for x and then solving, I have to put it in for the y value. And so I still have to solve by doing an opposite operation. So I'm going to do an opposite operation. I'm going to go ahead and divide by 10. And that gives me 6.3 hours. Well, what's that 0.3 mean? So we need to figure that out. So let's go ahead and change that 0.3 to minutes. So let's go ahead and do 0.3 hours. And then we're going to multiply that by 60 minutes per hour. So if I multiply by 60 minutes, that'll give me the number of hours that represents. And so that equals, and then if I multiply 60 times 3, I get 18 minutes. So it's 18 minutes is what that amount was. And so far I have 6 hours and 18 minutes plus the 18 minutes plus, so that was the 6.3 hours there, plus the extra 15 minutes it takes to get to the seats. So 15 minutes. And so I add those numbers up and I get 6 hours and 33 minutes. So now what we need to do is I need to find out when I should leave. Well, the game starts at 7 p.m. So let's do this. Let's subtract those two amounts. 7 p.m. minus 6 hours and 33 minutes. Now the way I'm going to write that is this. 33/60ths. Now the reason I do that is because there's 60 minutes in an hour. And so I'm going to end up having to borrow a little bit. So I'm going to borrow from the 7, change that to a 6, and add the 60/60ths. And so when I go ahead and do that work, I end up with 27 minutes. Now, what time would that end up being? Well, 7 p.m., if I take away 6 hours, that's 1 p.m. Well, if I do 6 minus 6, that means I'm at 0, and that represents 12 o'clock. And so it's going to be 12 p.m. and 27/60 minutes. So that means it's 12:27 p.m. That's when I need to leave in order to get to my destination on time. But then it says Ned has a meeting, and the meeting lasts between 12 and 2. So when will Ned be able to see the opening kickoff? No. If not, and the reason he can't is because he has to leave by 12:27. So he's going to miss the opening kickoff. Now, if not, what rate must Ned bike? So he's not going to be able to make it. He's going to miss it, yes. We'll say, actually they ask, is he going to end up making the opening kickoff? And no, he won't. So, no, Ned needs to bike faster. So we will need to find out how much faster does Ned need to bike. Well, here's what we're going to do. We're going to look to see if he's going to leave at 2 p.m., how much time does he have? Well, let's start with 7. We'll start with the 2 p.m., but let's add on that extra 15 minutes to get to the seat. So we're going to go 7, and we're going to take away the 2 hours, 2 and 15/60. And the reason 15/60 is there because it takes 15 minutes for him to get to his seat. And so I'm going to go ahead and do some subtraction. So I'm going to change that to 6, and this to 60/60. And then I'll go ahead and do that subtraction. I get 4 hours and 45 minutes. That's how much time he needs. So he needs that amount of time to get to his destination. So what we're going to do now is we're going to do 63. I'm going to go ahead and define a variable here. R equals the rate Ned needs to bike. So I'm going to do 63. So 63 came from, that's the amount of miles it is that he needs to go, equals, and then I've got the rate at which he needs to bike times by the time, and he needs 4 hours and 45 minutes. So I'm going to change that 4 hours and 45 minutes to a little bit easier number to understand. So I'm going to divide it by 15/15, and that makes it 4 hours and then 15, let's see, that makes 3/4. So 4 3/4, so 4.75 we'll say. And so now I'm going to go ahead and do a division problem. So I'm going to divide by that 4.75. It's not going to really go in there too evenly. And so I go ahead and do that division, and this is the number I got on the calculator. It was, let's see, it was 13.26, and then it kept on going 315, and then it kept on going. So I'm going to round this to the nearest tenth. So 13.3 miles per hour is the rate at which he needs to end up biking in order to get to the game on time. So those are the types of problems you'll see on that performance task. Good luck.